Okay, so I'm going to read it again so that makes sense. So we have ASA postulate. Two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, and the two triangles are congruent. So again, that included side, you notice that's even written with the side S in the middle, S-A-S-A. We're going to add this one to our sideboard. Here we have the angle side postulate. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of a second triangle, then the two triangles are congruent. So here we see that it's a non-included side. We have an angle, we have another angle, and then the side that is not between them. Congruent angle, and then the side not between them. So I tried to draw these on, and this is why I did not continue. To see how lovely they look. So I'm going to write over them in my black pen so you can see what they were supposed to look like. A and B didn't look so terrible. C is a little difficult. And then over here we have E, D, and F. Over here we have H, G, I, or that's supposed to be a J. And then we have M, K, and L. So the rest of those look okay. On the bottom one, you guys should have P, Q, S, R, and then we see that these two. Okay, so our first one asks, can you use angle side angle to prove that the triangles are congruent? So we look at the first one and we see that angle A is congruent to which angle? Angle D, yep. And then angle B is congruent to which angle? Yep, angle C. And we see that side AB is congruent to side. So be careful. I know that I just wrote them close. The C goes with this first triangle.
Oh, ED?
Yep, ED. It's just the way it turned out writing. So it should be side ED. Okay, so do we have enough information to use angle side angle?
Yeah.
We do, because we have angle, included side, angle. Angle, included side, angle. So yes, we have enough information. Okay, for our next one, we see, I'm going to write above it to make sure I have enough. Angle J is congruent to which angle? J is congruent to? I think I hear you saying M. And we see that angle G is congruent to
Okay.
angle K. And we see that side HJ is congruent to KM. Can we use angle side angle here? So here we have angle, side, angle. All of them are congruent to something in the other triangle, and the side is included. Over here we have angle, side, angle. This one does not have an included side. It's not between our two angles. We cannot use it. It has to make sure that it is with the congruent to the side that is between the two congruent angles. So no, we cannot. So no, we can't. Question number 2 asks, what additional congruence is needed to show that triangle PQPS and is congruent to triangle QRS? So our two smaller ones by angle, side. And remember this one does not, the side is not included, so it's the non-included side here. Okay? So what else needs to be shown? So we know that angle Q is congruent to, yeah, I should have written that out. I apologize. Let's write it as the 3 letters. So angle PQS is congruent to angle SQR. And we also know one other thing based on this picture. What do we know? Yep, we know that QS is congruent to QS by that reflexive property. I'm going to write reflect. Okay, so our goal is to see what else we'd have to prove. What else is needed to show angle, angle, side? So 2 angles and the non-included side. So if we proved angle S, that would be the included side. So which one would we need to show for it to be the non-included side? Do you know what I'm asking? Okay, so up here it was angle, side, angle. Angle, included side, angle. But down here it is angle, angle, side. That is the non-included side. That's why it's out to the back. So we have 2 angles and the non-included side. So it cannot be set up like this. So here we have an angle and we have a side. And our next angle has to be one that's not going to include this side. So which angle would we need? Angle S or angle P to show us that this is the non-included side? We'd need angle P, right? Because if we did angle S, that's now going to be that included side. So angle P has to be to show it's congruent to angle R. Angle P is congruent to angle R. Does that make sense? Do you guys feel okay with that? Are the triangles congruent? If so, by which theorem? So now we have 4 things in our toolbox. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. So based on this first one, we look at this. We have one angle is congruent to this angle, and this angle is congruent to this angle. What else do we know? There's one more thing that we've been using all day. Yep, AC is going to be congruent to AC by that reflect property. Now I know this. So, which theorem proves that? We have an angle, we have another angle, and we have a side. Is that the included side? Is it between these 2 angles? It's not, right? It's the non-included side. So that's going to be angle, angle, side. For B, we go over here, and we see that this side is congruent to this side, and this angle is congruent to this angle. But what else do we know? We can't, that is true, but it doesn't help us in this case because the whole side of this triangle is not going to be that length. But that is true. You did say a true statement. We don't have enough information in this case. We can't prove another side or another angle that's going to help us. So not enough info. And then our last one here, we see we have an angle that's congruent to another angle, an angle that's congruent to another angle. Okay, you ready, Mantu? This is your question again. So what else do we know? We know that
KM is congruent to KM.
Yep, it's congruent to Km. So we know that this is congruent. So which theorem proves this? Which postulate? So we have angle, included, side, angle. So that's going to be angle, side, angle. That's going to let that happen. So statements and reasons. So our first part is we are going to write out what we know. We know for step 1 that angle GFH is congruent to angle JGK. And we know this because it's given in the photo. We also know that GF, segment GF, is congruent to segment JG. We have to show one other thing to prove that these are congruent. So it's going to be 3, 4, 3, 4, 2 again was given. So what do we have to show that these are congruent? So we see that these arrows tell us that these are parallel. So we have 2 parallel lines cut by a transversal. So when we have 2 parallel lines cut by a transversal, what do we know about these 2 angles? They're what type of angle? Are they alternate interior, alternate exterior, corresponding? What was my other ones? Same side interior. I thought I heard you say mine too. Did you say it?
I'll say corresponding.
They're corresponding. So we see that those are corresponding angles. So we see that angle FGH is going to be congruent to angle GJK because they are corresponding angles. Definition of corresponding angles. Okay. Our last statement is going to be triangle FGH is congruent to triangle GJK. And 4 is because angle, side, angle.